In this video, we will review the idea of proportionality, but let's start by reviewing the idea of using division as a measure of relative size. So recall that A is A divided by B times as large as B. So this fraction, A divided by B, tells us the size of A relative to B, or it's the measure of A in units of B. So down here in this diagram, I have a segment with two segments, one representing the value of A, one representing the value of B. If we imagine measuring A in units of B, that measurement is 2.5 because A is 2.5 times as large as B. So if we're thinking of A divided by B as the measure of A in units of B, then A divided by B should be equal to 2.5. Then, proportional relationship is a relationship where two quantities' values vary together such that the values always have the same relative size. So suppose y is proportional to x. This means that the size of y relative to x is constant. And we can represent the size of y relative to x, or the measure of y in units of x, using the fraction y divided by x. And since y is proportional to x, this relative size is constant, or this ratio is equal to a constant number c. We can also think of this as y being a constant number of times as large as x. And so y is equal to c times x, where c again is a constant number. So let's look at an example with some numbers. Suppose x and y vary together such that y is always 3 times as large as x. Since y is always 3 times as large as x, the size of y relative to x, so the size of y relative to x, is always equal to 3. So if we measure y using x, that measurement is always 3. We can also write this as y is always 3 times as large as x. Now if we look at a table of values, anytime we know a value of x, like x equals -3, we know y is 3 times as large as that value of x. So when x equals -3, y is equal to -9. If x is equal to 0, then y is 3 times as large, so y is equal to 0. Again, if x is equal to 1.5, then y is going to be 3 times as large, so y will be equal to 4.5. We can also think about this relationship graphically. So here I have two segments, one representing the value of y, one representing the value of x, and I can vary the value of x. And as I vary the value of x, both of these segments vary to represent the corresponding values of x and y. So as I vary the value of x, notice that y is always 3 times as large as x. This segment representing the value of y is always 3 times as long as the segment representing the value of x. Doesn't matter what the value of x is, that segment for y is always 3 times as long. So if we measure the value of y using x, that measurement is constantly 3. So if we were to represent this value of x on a horizontal axis, value of y on a vertical axis, and then coordinated these two values, so we would plot a point where those two dashed segments intersect. And as we vary x, or as x and y vary together, we trace that point to create a graph of the relationship between x and y. We notice that this relationship is a line passing through the origin.